Okay. So the objectives of tonight are to reiterate and discuss what we talked about. Is Courtney not here no more, but she'll be back probably. Reiterate. Hey, Monica, how are you? Reiterate and discuss what we talked about last week at a very high level. Of course, I'm not gonna go like super in depth like what we talked about last week, but I will touch on it a little bit to refresh it. So discuss what we talked about last week. Um, in addition to that, the other objectives were logical operators, aggregate functions, ordering, filtering, and categorizing within the aggregate function space. So, do we have any questions before we get started? All right. So, let me record and let's get this thing going. So, to reiterate what we did last week we talked about those DML languages, which was a data manipulation language. Insert, update, delete, and select. We talked about those, and I wanted to reiterate the expectations of those, the format. And I know y'all have already had the opportunity to do your coding challenges, so you got the opportunity to practice that a little bit. I've been seeing y'all on LinkedIn pop out a little bit, so I love what I see for the record. But to reiterate, so this select is used to retrieve that data, select whatever columns you need from whatever table you're retrieving that data from. Insert is used to insert data into the table. Insert into the table name, your columns, your values. All three of these have to be in the exact same order in order to successfully insert. And they also have to have the ideal data type as well. If you're trying to insert a different data type into a column that's another data type, it's gonna like be like what you're trying to do. Update. When you are updating that table, update table name, set this column to whatever your updated value is, where this column equals that, where this condition is met. And remember, this is called a condition. This is going to be helpful for y'all tonight because what we're going to lean into heavily, we're going to heavily talk about like conditions and filters, and y'all are going to apply those as well. Delete. Delete from table name where this column equals this, where this condition is met. Remember, everything we're doing is tables and columns. Everything has to explicitly outline, and anything that we're doing goes back to a table and a column. These cannot coexist. They are all doing different things. You're either selecting data or you manipulating the data. So we retrieving or we are manipulating. See the two of them things. So that's at a high level what we talked about last week. And I know, like I said, y'all have got the opportunity to do y'all's coding challenges to practice those. And it looked like everything I see, y'all grasping it. But did y'all have any questions about this? Okay, say less then. Say less. So first tonight, at our in addition to refresh, one of our main objective tonight is a logical operator. So, here it is. So, what are logical operators? Logical operators are essentially used within SQL to combine multiple conditions within their where clause. When you discuss those logical operators, that's when you get into like that data querying, data filtering, and ideally is to control like the conditional logic to retrieve like certain data sets. It really allows you as an analytic professional to niche down on what exactly you are trying to capture. It also supports, I actually had a consultation today when I was talking through some data. It also supports you to be able to test your data. If you're looking for a certain condition, if you're looking for a certain condition or a certain data set, those logical operators really help you to niche down. Now, remember what I was saying from the very beginning. Anytime we are within SQL, you are either selecting, inserting, updating, and deleting. These logical operators go right underneath whatever you're doing. Just like if you recall in our update statement, we're updating this table, setting this column where this condition is met. If I was to add another logical operator, I could say, and this condition is met, and that condition is met. They can literally go on forever. And the purpose of them is, let's say you have a data set and you have 3 million records within your data set. And your goal is you're trying to niche down as much as possible to filter out to do your analysis. That is where you would use those logical operators. So the primary logical operators are and, or, not, between, in. Not at the same time, but those are like, that's it. And the way that you format them is you are literally selecting whatever columns you want from your table, just like we do all the time, where this condition, this column equals this condition, and this column is greater than, less than, equal to this number. This is where and. When you use and as your logical operator, I'm basically saying, pull me all the data where all of these conditions are met. I need everything. Give me this and give me that. Give me 2 of them too. Give me 3 of them too. Like, just you get everything. When I'm filtering out my data, the output or the result of my data set will meet, they have to meet all the conditions that I say. So within this output, I'm selecting these columns from this table where this department equals IT and this salary is greater than 50. My output will have all the data from this table where both of these conditions are met. They both got to be met. Or select these columns from this table where this column equals this, or this department equals this. Or essentially says, does it meet this condition or this condition? I want both of them. Let's bring back the data from this condition or this condition. I'm not really picky. I want both sets of data. I want both conditions to be included within my output. Not does exactly what it sounds like. It negates a condition. Did I say condition? Yeah, I did. Select this column from this table where not this column equals IT. Now, there are multiple ways that you can do not. You can say not like this, or you can do this. I typed it in the chat. The equal sign and exclamation sign. If I say select these columns from this table where equal sign, exclamation point, this column, where this column, equal sign, exclamation point right here, IT. Basically saying where it's not IT. Anything you're going to pull back, it means that it does not meet that condition. It is not true. Between. So between, when I use between, typically when you use between, it could say it's essentially a range. It's essentially a range. But that range can be applied to dates, numbers. Dates, numbers, like how it is here. This is saying where salary between these numbers. Where dates, if I say I want all the data that have an order date of the month of March, you would say between this date and that date. You still using where, you still using your same column. However, your ideal logical operator to check in between those parameters or those ranges would be between this value and that value. And you can still even add more logical operators to this. select all from employees where salary between 40,000 and 70,000 and state of residence this and state of, whatever your conditions are, it can literally keep going. Like your code, when I told y'all in session 1, I don't care if your code is 6 or 60. I don't care if it's 600. Your foundational structure will remain the same. You essentially are building upon what you already know. And as you get more complex within your analysis, as we get complex within these courses, the way that I will recommend you navigate their space is start from the foundation. When you are building out your query to answer a question, okay, go and do your data investigation. This is from this table. These are from this table. This from this table. And start from, select from this table. Then go to your columns. Like start from as bare bones as possible because it helps you build. It's easier to build than it is to like go and try to look at a bigger picture. I think what's the saying? You got to eat an elephant one bite at a time. One bite at a time. I was having a consultation today, and essentially the issue was she was trying to create some case statements to create to capture certain logics. If, in which we'll talk about that next week. If this condition is met, then this. Those are case statements. They meet the condition, and then they produce the data based on it. However, the data that she was validating, her data set that she was getting was like 10%, only 10% of what the expected output was. So she was going through her query trying to figure out, okay, what am I doing? What am I doing? She looking at the code, looking at the code, looking at the code. And I'm like, you know what? Believe it or not, you're jumping the gun by looking at your code only due to the fact of you don't even know if the data sets that you're comparing are the same data sets. So start from the bare beginning. Always start from the source. Always start from the bare bones and literally build upon it. The same way how you cook or same way how you do anything. We start, when we get dressed, we start from the bare and we build it. Because it helps you understand, even when you have multiple conditions within your code, you can add what you need and count, and you will see the data dwindle down based on what you add within your logic. And just apply it to anyway. And that way you don't get intimidated when you have to join multiple tables or you got to do this or you got to do that. It don't matter because you're going to start from the bones anyway. So between N, this is essentially when you have multiple values within the same column. Like here, we got select these columns from this table where this column N, multiple values, IT, HR, finance. I want it all. Give me all that. When you have multiple things, multiple values within your columns, using N, it's just a cleaner way to write your code. Because it could be, if it's any of these things, I need it back. So these are your logical operators. You add those onto your existing code, and it allows you to filter down explicitly what you are trying to get. Y'all got any questions? Okay. Is everybody connected to the, okay, everybody connected to the VM? Okay. So tonight, I'm gonna walk you through this again. Tonight, you're gonna do more of the driving. I'm gonna do more of like, I'm a cruise, but I'm a coach. Not like you, Courtney. I ain't got nothing on you, but I'm a cruise, and I'm gonna coach y'all how to like think through it, talk through it, and what the expectations are. So refresher, because we got to refresh. This is your server. Hold on, I can't see it. It's too small. Hold on, y'all. Okay, here it is. This is your server. These are your databases here. Expand your database. These are your databases here. Tonight, let's go within our customer order DB. You know what? Just for you, Monica. Just for you. Let's go within our healthcare system database. Expand it. And then you have access to your tables here. Expand your tables. Let me look at the data because I am going to provide you with some use cases. And okay, let me pull the data. So we're in the healthcare system database. And I am going to okay. So we're in the healthcare system database. I am going to give you the use case in the chat. And I'm gonna say it out loud because the recording doesn't pick up on you on the chat. So I'm gonna give you the use case. We are using the healthcare system database. I'm gonna give you the use case. What you need to do after you get your use case is, first of all, do some data investigation and figure out, right click your tables, select top 1000, right click, select top 1000, and figure out firstly, which table answers this question. What table answers, that's your data investigation. What table answers, what column, what tables, and what columns. So I'm going to give you the use case and make sure that you document what you're doing at the top as well by document this query does whatever you're doing. So you can document your code. Okay. All right, so I'm gonna type the use case in the chat. And then I'm gonna say it out loud. I'm looking at my data too. And I like to write, I like to do it with y'all. Okay. So I need a data extract of the patient ID, the test name, the result of test, where the tests were taken in 2022, and the result was abnormal. So I'm going to leave my logical operators up here. First step, data investigation. Which tables answer this question? Which tables answer this question? Second step, which columns answers this question? What data do they need? Data investigation, what data set do they need? Third step, which logical operator is appropriate for this? So I'm gonna leave these here. And if you get caught up on something, just like raise your hand. We can walk through it if your code doesn't work. But I'm gonna give everybody a few minutes. And remember to remove your top 1000. Because when we right click and select top 1000, it's gonna automatically limit out the number of data we get. Also, make sure that you're actually looking at your data to make sure that you're capturing exactly what needs to be captured in the way that it needs to be captured, because it has to match like explicitly. Okay. How y'all doing?
Lorita, I'm having trouble with the date part.
Okay, let's talk through it. You want to share your screen?
Yes.
Okay. Let me stop. I already know what your problem is. And when you see it, you're going to be like, oh. Okay, I'm going to put it on the big screen so I can see it. Okay. All right. So let's talk through it. On line 11, okay, this quick. Okay, perfect. Your documentation is good. That's best practice. Coming out line 11 and re-execute your code and go look at your data. Oh, you could have kept it and just like do the 2 dashes like you did on one, but it don't matter. Okay. Look at how your actual data is within that table. So you got where, which is correct. You had the column, which is correct. Where the ball was dropped was the format. So you would say for test date. And with this, it's a logical operator because we're testing the values. We're testing like a range. So if I say I want, oh, here it is. If I say I want the test date in the year 2022, what dates make up 2022? And I'm going to share my screen so you can see which logical operator you need to use. I told you when you see it, you're going to be like, oh, okay. Those where column name where column name between the two fields, two values. But the format of those dates or the format of those time or numbers or whatever, it has to explicitly match. Yep. Mm-hmm. Yes, ma'am. Now you're getting a date type error, and it is attributed to the dates in there. You got to make those strings the same way you made the data string. And the reason being is because it's saying that, okay, within the table, it's a date type, date time. But within your code, it's pulling it like it's an integer. Perfect. Come through. So you did multiple things. The first thing is your data investigation. This is my data. This is my request. This is my ask. Where is this data? Where even is this? Selecting. You got your appropriate columns from this table where this condition is met, where this column between these two values and the result equals abnormal. Very good. Very good. Did everybody else get that? I know that date got y'all though. I know it did.
The date stumped me on, I think it was last week's weekly challenge, so I learned from the coding challenge.
Oh, yeah, because it didn't structure format correctly. The dates will still give me some time. Like if I'm writing code and I'm like, that is not what this is. I got to go back and look. Eliana, what were you did you get it after you see Courtney? Okay, good. Now, I'm about to write it in the chat, but y'all, you just got another ad hoc request. But we're gonna use, it's the same, but I just need a different data set. Let me see. Okay, so now I need where the test or where the result is abnormal or it is a severe issue. So the same parameters, same date, time, same all of that. However, I need to see where it is abnormal or a severe issue.
Lorita, can I go back and share my screen with you?
Mm-hmm. Okay.
This is what I'm getting.
Is that what is that at the result? It's saying that. Oh yeah, what is that at the result? What sign is it? I can't really see. It's blurry, but it can't be.
It was a. Oh, okay. Should it be a equal? Okay, that's where I messed up. Maybe it's just a dash.
Oh no, girl, that dash. It got to be an equal sign. Because we're saying where this column equals this.
Yes, that's right.
Now execute.
Okay, let me. Okay, got it. Thank you.
Perfect. You're welcome. Now this one I need where the result said. I mean, not result said. Oh, where the result is abnormal or is a severe issue. Or result abnormal and severe issue, rather, both of them. Not or. I want my results to have severe issues and abnormal and fall within their date range. Uh-oh. Trying to find my. Oh, here it is. And if you want to talk through it, let me know. Remember, if you are using the same column but multiple values within that column, you will use N. And don't reinvent the wheel. You in a position and you already got some code somewhere that does something similar to what you're trying to do. Use that old code. Ain't nobody gonna know. Use that old code and doctor it up to capture whatever your new output is. I keep all my code. I like everything. Just a hack, a tip. Hey, y'all coming?
On mine, I used N for abnormal and severe issue as the result,
Mm-hmm.
but it's only pulling severe issue.
Can you share your screen?
I'll give it a try.
Or either I can share my code and we can look at it. But I don't like doing that because I be wanting y'all to think through it because mine might not be explicitly like yours.
Yes, share this window.
Okay, I'm gonna put you up on my big screen so I can see. It's black or it is not coming up.
Let me try. How about now?
You probably got some kind of privacy block on there or something. I can share mine.
Okay, I want me to share the code with you?
Yeah, do that because we have the exact same data. Great idea.
Let's see. It says I'm sharing, but I don't know. Okay, I'll just share the code.
Okay. And let's walk through it together. Okay. So I'm about to copy it and I'm about to put it in here. Share my screen. So, okay. Okay, so we got the patient ID, test name, test date, result from the table where test date between this value and result in. Oh, you know what's wrong with your code?
I don't.
ABNOR.
I saw it too.
I was spelling.
Yep. Because I'm like, this looks right. And there we go.
Okay. Disregard.
I do that. I did it so bad one time that I called my teammate in. But to my defense, it was a lot of code, and I had been writing code all day. I had like two values spelled wrong, and I was like, "What's wrong with this? Help me!" And I was like, "You know what? That's it. But you're good. That was the problem." One more using logical operators, and then we are going to. This was my code, which was essentially the same thing as yours. I just had them switched around. But one more logical operator, and then we are going to go into our aggregate function. Oh, and another thing, one thing, I know I wanted to go over order by with y'all tonight as well. Order by goes hand in hand with like they're filtering out their data set. And the way that it works is this. Let me show you. I got a thing right here. Order by is essentially a clause, and it literally orders by whatever that column is by ascending or descending order. So in this example, we say order by this column ascending. Basically, whatever values that are in that column, order those by ascending order or descending order. So if you could you order it by the date in ascending order? Order it by the test date in ascending order. And that goes into that helps you test your data as well. It just orders it, keeps everything structured in order. Ascending is ascending order. DESC is descending order. That's in the event that you are like doing some data investigation, doing some analysis, and you like, but what's the range, or what's the last date that somebody did, or whatever. When you're trying to see like the first or the last, that's helpful in utilizing it. One more, and then we'll go into our aggregate function. So I'm typing the use case in the chat, and I am going to say it out loud so it can be on y'all recording. Provide me with the data extract the patient ID, doctor ID, status ID. Okay. So provide me a data extract with the patient ID. Oh, I'm showing y'all the answer. Hold on, stop. Okay. Provide me with the patient ID, the doctor ID, and the status of all appointments that were canceled and they were for a checkup. Now, remember how last week I talked to you about how when you right-click a table and the system automatically generates and it puts those brackets around the tables. And the reason being is because there are times to where your column names might actually be reserved words, but it's a column name. Status is one of those things. Status is an actual reserved word within SQL, and that's when you get into like that DBA administrative work because it checks the status of like the database. So with that being said, make sure that you do your square brackets around your columns, at least for this use case. So data extract of the patient ID, doctor ID, and the status of all appointments that were canceled for a checkup. First step, data investigation. Which tables answer these? Which columns answer these? How's that data structured? Make sure you document what your code is doing too. Just get into practice the documentation. Because people gonna talk about you if no, it's fine. They ain't gonna talk about you. I wouldn't care. But like in the event, you gotta share your code so people can like know what you're doing. I don't like when people don't document. I'd be like, why? Well, how am I supposed to know what this do? Give me 1 second. Let me grab some water. All right. How y'all doing? Or if anybody want to share theirs. Okay. So she said her code not working. Let's see why her code is not working. Oh, you got to put square brackets around status. It's probably why. Yeah. Because see, it's blue. It turned blue. It's a reserved word. So let's walk through her code. Okay. So this is, I'm going to document. I'm documenting whose it is. Okay, so we got our appointment ID. So, okay, so we need the patient ID. So add the patient ID. So patient ID, doctor ID, we got that. Patient ID, doctor ID, status of all appointments. So I'm gonna pull the status too. So patient ID, doctor ID. Put my commas here, and I'm cleaning it up a little bit. Okay. So patient ID, doctor ID, appointment ID, and status from the appointment where the status is canceled and the reason is checkup. So let me look at the data from the appointments table and see if, yeah. So I'm just gonna put it in brackets, just keep everything consistent and execute. And it's saying the data type, text, barcode are incompatible in the equal operator where status equals, let me just work on mine, start from the beginning. So I got the appointment ID. I'm going to remove the top 1,000. Appointment ID, patient ID. Where status equals cancel. So let's start there. Where status equals cancel. We got that. And and reason equals, what did I say? Checkup. Oh, okay. Okay, so it's saying that my data types are not working. So I'm gonna go look at my data. I got my appointment. Oh, reason. Why is that a text? So let me get rid of this. I'm trying to figure out, the issue is coming from, I think I inadvertently did this data type wrong. The issue is coming from, this error is attributed to the data type. So I put, Eliana, your code was correct. The way you had it with and reason equals like checkup like this, that is correct. However, it is giving me the issue because of the data type. So I go over here and I do some data investigation. I look at the data type and it's actually pulling a text data type and not a varchar. So that's the only issue with that. So I'm just gonna get rid of that and go back later and change that data type. Or I might get y'all to do that while we on the call, but
The same message. So
I don't know why that oh, so I need to do a substring. We'll talk about substrings next week, but I am this should be a reason. This should be a varchar, the same way as status. So that's why the status comes up. But I'm gonna go and update that. Yeah, I go out to the table probably tomorrow. But where status is canceled and appointment date, let's do the appointment date instead of the reason. Let's do the appointment date of December of 2024. They're trying to do some analysis to see if they should schedule checkups during that time. Are people canceling their checkups or are they coming? Any questions? You got it, Courtney. I saw you over there.
Yeah, the dates won't screw me up this time.
Good. All it takes is one time.
Yeah.
All it takes is, yep. And then even when it comes to like I just got tripped up on the date time. I mean on the data type within that where are we? So we in the appointments table. Oh, within the appointments table within this reason column. That text threw me off. I didn't realize I created that table with that data type as a text. It should be a varchar. Because with text, you got to pull out like a substring. It's basically it basically reads it like a text, and you got to say substring and then type the substring. But we'll get into manipulating substrings next week. But so yeah, select all your columns from your table where this condition is met and that condition is met. That's those logical operators. You can build it as complex as you want. And you also, as you progress within data and you go into joining tables and using case statements and window functions and CTEs and views and all that stuff that we're going to touch, those logical operators and filters, literally, they build upon that. Where this condition is met, you just keep building, just keep going. So, any questions about those? Okay. So far we have done the logical operators and ordering our data, ordering by ascending, descending order. So next it is aggregate functions. Well, let me make this big. Okay, can y'all see my screen? So aggregate functions are when you get into like analysis, data analysis. That's when you get into computing large data sets, really to give you like that statistics part, but not really statistics, because when you say that it's like, but anytime you are in the position to calculate or provide a high level description of what is taking place over like a large data set. So the aggregate functions that we are going to focus on are sum, average, count, max, and min. And they do exactly what they say that they're going to do. Now, we have select, which is what we do all the time. Sum, this is our aggregate function. Whatever column you are performing your aggregate function on has to go right after your aggregate function in parentheses. Select aggregate function, column name from table. That sum pulls you back the sum of that column. And it's going to pull back one. The truest definition, like if you want to get into Webster's, it's going to pull back one single statistic, one single number. And within your aggregate function, it's actually not going to name your column. And I'm going to explain that in a minute, and because you're going to have to like give your column an alias. And the reason being is because you're calculating. You could be calculating multiple columns against each other. I can say the average of this, or the sum of that, or multiple columns. So you have to explicitly capture what you are calculating within your output. So select sum, column name from this table. Average. Average goes, it does exactly what it says it's going to do. It's going to select the average, this column name from this table. Count. Give me a count of records. Now, when I say count, it's literally pulling back the count of records within that table. That's why it doesn't have a column. You put the star in the column because I want everything. Select count from this table where this customer's from here, where this condition is met, where you can add those filters right underneath this count because it filters out what your total count is. Total count is just a total count of that table. Max. Select max, column name from table. Bring me the max value from that column. That will help support you in the event that you are organizing, organizing your data, in the event that you need some sort of insight on what are these people, like if you say for money or something like that, what are these people spending their money on? What's the maximum price that they're willing to pay for this particular product? Those type of questions. Min returns the minimum value of that column. What's the smallest amount that's going to return back for that column? Now, what we're going to do tonight is not only are we going to do our aggregate functions, I'm also going to walk you through categorizing your data within those aggregate functions. Provide me a calculation, but categorize it by groups of that data set. Because within my aggregate function, I'm going to, when I say select sum, purchase amount from table name, it's going to bring me back one record. And it's literally going to be the sum of this column. Let's say I want the sum of the purchase amount by customer, or the sum of purchase amount by order, or I need it to be broken down by groups. That way you have to categorize your data in addition to your aggregate functions. And we'll talk about that as well. And we'll talk about how to format that within your code. So keep in mind that aggregate function, that's when you get into like the computational part, that data aggregation, that summarization. That's when we get into that analysis. Any questions? Let's go then. Now for this one, let's actually use our customer order DB. Let's use our customer order DB, and okay. So I'm going to type the use case in the chat. First step, investigate your data. Investigate your data to answer the use case. Okay, I'm going to start with this one. Now for this one, since it's kind of ambiguous, I will tell you that you will use your orders table. And all I want is the average total amount. I don't need anything else, any more columns, anything else.
Where did I find customer orders?
Huh?
Customer orders. You said go back to the
Oh,
table.
the customer order DB or orders. I think it has orders DB.
Orders.
It's the orders database.
Okay. Yeah, I see that one. Okay.
And it's the orders database in the orders table. And all I want is the average total amount. And let me know if y'all want to talk through it. If y'all Okay. I was doing y'all next use case. Y'all good? I just need the average total amount, and we're going to walk through that, and I'm going to show you how to alias it. I'm also going to utilize this table to show you how to categorize your data set as well. All right. Y'all good? So, okay, good. So, within the use case was a data extract of the average total amount. So, here I have my select statement. Let me document what I'm doing. Okay. So, I have my select statement. I right clicked and just selected my data. So it pulled out all the columns. So I went through and I'm like, okay, I don't need this. I don't need this. I don't need any of this. The only column that I needed was the average total amount. So here I have my average, my aggregate function. I have the column that I'm performing the aggregate function on in parentheses from the table name. Now, notice this has down here no column name. So in order to eliminate that, I have to name my column. I have to essentially, the reason why it does that is because it's basically like, I don't know what the calculation is, or that's what the system said. I don't know what you calculate. So in order to eliminate the no column name, you have to give it what is called an alias. And remember that because we're going to talk about aliases in detail next week. An alias is essentially this is what this is, but I'm going to call it that. Same way how we use it in our natural language. So average total amount as, what am I calculating? And execute, and it changes the column name to adequately capture whatever your calculation is doing. Now, remember how I told y'all, and I said when you do an aggregate function, that aggregate function only returns back one record. Let's say I need to identify the average total amount by customer, but I also want the order date as well. I want the average total amount by customer, but I also want their order date. Anything that we put in our select statement is what we have what we expect to have in our output. So here I have the average total amount as average total amount. That's what we got. But I also want the customer ID and the order date. So I have to include that within my select statement. So I have select, customer ID, order date, average. It's my aggregate function. This is the column that I'm applying the aggregate function to. This is my alias. This is what I'm calling it from this table. Now, whenever you are applying an aggregate function to your syntax, anything within your code that is not an aggregate function, you have to group it. Because I'm telling you to calculate this, but I also need you to group it by customer ID, and order date, because these are not included within the calculation. So I can't just calculate it. You got to calculate it and categorize it. How you would do that is I select this column, my aggregate function as average total amount from this table, group by. Anything that is not included in your aggregate function, you have to group it by. And as a matter of fact, if you try to execute it without it, it is going, oh, okay. It's only doing it because I got it. Oh, I don't have my column. My comma. So let me add my comma. If you try to do it, execute it without a group by, it's going to tell you it's invalid in the select list. It's telling you that customer order, that customer ID is invalid in the select list because it is not contained in either the aggregate function. They said it is not an aggregate function, or is it in a group by clause. So if it's not an aggregate function, I have to group by. I have to group it. And if you try to execute it without grouping it, it's going to give you a syntax error. So when I group it, I got my customer ID here, my order date here, my average total amount here. Anything that I'm not calculating, I got to group it. If it's not calculated, it has to be grouped. I'm calculating one column, but group that one column by my customer and my order date. And here you will get your customer ID, your order date, and your average total amount. This essentially answers the question is, what's the average total amount of each customer? And what day did they place their order? This is when you get into answering like those questions with numbers. In sports, it would say, what was the average batting average of what was the average batting average of this particular player within last year? In healthcare, what is the average blood pressure? What's the average weight? What's the average this? What's the average that? What's the sum of this? What's the sum of this medication? Or however it works within healthcare. Finance. What was taxes? What was the average taxes that this person paid based on this salary within last year? Like, you can literally calculate whatever your domain is, whatever, any questions that you consistently answer that provide you to calculate. This is where you will use those aggregate functions. This is the analysis and statistics part. Any questions? And even here, I can order by, let's order by order date. Where, take it a step further, I would have to put my where statement after from, where order date between, let's do 2024, you building upon it. Select customer ID, order date, average total amount from this table, where order date between these values, group it by, order it by. Let's say I want the order date between and the whatever other condition. You just add it right on to there. Build, like, layer it. I'm gonna give y'all one more aggregate function with within this database, and then we're gonna go into another table, but with logical operators using your aggregate functions. Is this making sense to y'all? I see. I have to. Oh yeah, I get it. I know. So, okay. So the next use case is. Let me see. Okay, I'm gonna type it in the chat, and I'm gonna type it in the chat, and I'm gonna say it out loud. It's the same database, but it's gonna be a different table. Okay, and we can walk through this if y'all want to. So the use case is, what is the max price and a product name of each category? So the first thing you're gonna have to do is go do some data investigation and see which out of these 5 tables answers the price, max price, or the categories, or the product name. Which of these tables has those 3 data points in it? Max price, price, category, and product name. First step, data investigation. And if anybody want to walk through that code or go through it, we can. Remember the aggregate function and then the column that you perform the aggregate function on. Anything that is not an aggregate function has to go, you got to group it. So select aggregate function, column name in parentheses. Whatever other columns, you got to group it by this column, that column, this column. Because I got to categorize it. I want you to calculate it, but I want you to categorize it too. You want to, okay. So I'm about to share Ileana's code. Okay, so we got, so my database is named differently than y'all. Okay, perfect. So we got, okay. So your aggregate, let's talk about your aggregate function. Okay, so I can tell you kind of did software before, Eliana. Because I see what you're trying to do, but I don't. I see what you're doing. I see you though. So you got all of this up here. So anytime we have our aggregate function, anything that we expect within our output needs to go within our select statement. Select these columns from this table. So we want the, let me see, max price. You in the, let me see. So firstly, let's go to our products table. It's in our products table. Because if we right click our products table, we have our category here, our product name here. So it's in our products table. So anything that we do within our select statement, select these columns from this table. That's going to be in our output. So this is your code. You got select here, but you got this where, max, from, you got all this down here. So this is like completely separate from your select statement. This max price is absolutely correct. However, it has to go up here. And it has to match the column, but you're in a different table. So let's just walk through it from here. So we got go from our products table and we want the max price. So we got max, put price in parentheses, like how you had it. Max price. So this is going to bring the max price, the max from this column, the price column. Now, we want the max price, the product name, and the category. So I don't need the product ID. I'm going to get rid of it. Rule of thumb number 3,682. Don't ever give somebody more data than they asked for, because they ain't going to do nothing but get you in trouble. Not in trouble, but you know, like, they ain't asked for that. So don't need the product ID. Product name. So I got my product name. I'm selecting product name, max price, as max price, or whatever you want to name it, maximum price or whatever. Category. These are 3 columns that we need: the product name, the max price, and the category. Now, anything that's not within our aggregate function, we need to group it. Because I'm telling you to bring me the max. Calculate the max from this column, but group it by product name and category, because those are not considered, they are not within the aggregate function. So group by product name, category. Anything after your select statement, that is what is going to be in your output. Anytime you are performing your aggregate function, got my aggregate function, I got my column that I'm performing the function on in parentheses. As whatever I'm calculating, I got max price. From this table, group by this column and that column. Now execute. And what it's going to do is it brings you back what you asked for. It's bringing you back the max price grouped by the product name and the category. Calculate this, but group these calculations. Calculate whatever this column, I got max here, men. Bring me the minimum price. I'm gonna change my thing to yeah, you do. You get in and be sure to if you want to talk through it, just put some time on my calendar and we'll talk through it. But it's gonna come with like repetition. It's gonna start being like muscle memory. Like you got your aggregate function and your calculation. I always think of this is my aggregate function. What am I performing this egg function on though? That's when you put it in parentheses. Your aggregate function, your parentheses from this table, group by, it either got to be an aggregate function or grouped. So yeah, it'll come with just doing your coding challenges and stuff. Like when you go to your coding challenge, think y'all got some aggregate functions this week. When you go to your coding challenge and when you look at it, it's just gonna come like from applying it and thinking through it. Like Eliana, like with yours, you got your select, but anything this down here is just like free. It's not connected to anything. It's not attached to anything. And what you did here was kind of like what you're going to have to do for your join. I see what you did. And also remember that whenever you're doing from, it's from a table. But that's it. We'll walk through it some more if you want to talk through it like next week. But always remember, we are always selecting from a table. We ain't never not. We'll never select from a column. We select columns from the tables, but we always are pulling from a table. Let's do then we do this. Oh yeah, we did the order details. Let's do our okay. So I am going to show my aggregate functions, and I'm going to give you the one last use case for tonight. I want you to, we're still within the orders DB, but we are utilizing a different table. Okay. So essentially with this one, we're going to start out high level. Provide me with a total count of customers. Do some data investigation. Which table answer that? Which syntax, like what logic do I need to capture that? I need the total count of customers. That's all I want. Excuse me. And if somebody want to share theirs, I walk through it, we can. But I need a total count of customers. And don't overthink it, because I got a feeling that's what y'all doing right now. Oh, okay. Okay. Courtney, I see yours. Let me go through Courtney's. Nothing wrong with your code. My database is just different. Perfect. Let me see what Eliana got. So, okay, Eliana, when you do the count, go do it like this. Do count and then start, open up your paren, start, close your paren. Because we're going to get a count of everything. But that's all you did, count and then start like that. Like that. Now, customer. Oh, okay. My database is different. Nothing wrong with your code. Okay. Now, this is the count of all the records within that customer table. Now, let me provide you with, so I got another data request, and it's my last one. So I need a total count of all customers that are from Colorado, Maryland, and New Hampshire that joined in the year of 2023. I just need a total count. You already got your table. What table? Now what columns? And if it helps you to honestly go back and like restart your query just so you can actually see the data itself, you can do it. Like go back and like select top 1000 from your customer table just so you can see like how the actual data is structured in there. And let me go back and show y'all the logical operators as well. Because this one is actually a logical operator. And the aggregate function. Okay. Okay. Go look at your data. Go look at your actual data and look at how your data is actually structured within your database. And make your code match that explicitly. The same way we did with your, the same way we had to do with the dates. Go back and make your data explicitly match. Also, within your count, you don't need okay, so let's talk about it. I'm about to share your screen. Share your code, and we'll talk about it. Okay, so this is, I can't type. So this is Eliana. So she got her select statement here. She got her count star. Then you have your column. So we don't need a column within this one, because when you are performing the aggregate function, your aggregate function, whatever column that you're calculating, goes within parentheses. And here within our parentheses, we got our star. So we basically saying, give me a count of everything. So I'm going to get rid of this column, but that's why. Now, the next thing, anytime you filtering out data, it goes after your table name. So we have select count star from our table name. Your filter goes after. We are selecting whatever one in our output from this table where this condition is met. Now the first one was state, where the state. So state. Also, I'm going to put the square brackets around it because state is a reserved word. So I got to cancel it out because it's my column name. I don't want SQL or the system to think that I'm checking the status of anything. State is a reserved word, just like status. So select count star from this table where state. Now, within our logical operators, when we have multiple values within the same column, we use in. So where state in, open up your parentheses. Now you got the right idea. However, within the actual data itself, let's do some data investigation. The state is listed in like this. So your code has to explicitly match what your actual data is. So we got where state in CO MD NH. So we got select count star from this table where state in these columns. Then the next one was the join in the year 2023. So I got where this condition is met, and the next condition we are using join date, and join date between so it's formatted in year, month, day. So I said 2023. So I'm year, month, day. And select count star from this table where this column in any of these values and this column between these two values. Now we execute. And you got 6. So that's what you did wrong. Count star, when you use a count star, you don't have to list your columns. Because count star is that's just it. I just want a total count. From this table where. Anytime you say where, that where got to go behind from. Think about it. It's no different than I say, I can't filter out anything if I don't tell you where I'm getting it from. So I got to go from the table first. I got to say select from this table. Now filter out that data. It's going like in order. Select from this table where these conditions are met. Your where gonna always go after your from. Always. Where this condition is met and this column between these two fields. So that's it. It was just the placement of your filtering your data. You literally filtering the data. If I'm filtering it, I gotta have the data first. So I'm retrieving the data first, and now I'm filtering it. Think about it like that. I can't filter it if I don't have the data. That's how you did. Your where was wrong and your column. But that was it. Any questions? Oh goodness. Oh, here we are. So, okay. So I talked about the group by. Group by is used to categorize like those columns. It groups it by those columns instead of like the whole data set. If I don't say group by, it's literally going to calculate their whole data set. If it's 2,682,000 whatever records, it's going to say the sum of this column for the whole table. Group it by categorizes it by each group. Select your column names, your column name that you aggregate function, group by whatever is not included. Having is used after group by, but it's to filter out that data. When we use where, we filter out individual rows before we aggregate it. Having calculates that data and then filters it out. Select this column from this table, group by this column, having this amount. You can literally say, I'm filtering it by the aggregate. And these are some of the key differences between like that filter, where, and having. They're both filters, but where is like the individual groups, having is like the groups after you already aggregated. You've calculated even more using having. It's like where on steroids. Just like next week, our last session, just like our last session, window functions. Window functions are like aggregate functions on steroids. Like they are very much so related, but they take it a step further. It's essentially like filtering out using those aggregates. And I know that this is a little layer. This is a step further. It's stretching you a little bit, but you flexible. And in the event that this is why you do like your, that was a bar. Didn't nobody even say nothing. But in the event that you do have to schedule some time with me, and we can walk through it together. We can continue to walk through it together. Use your coding challenges to like practice this, because the more you practice it, the more organic it's gonna come. It's just gonna take like muscle memory, like literally lifting weights, literally working out. It's just gonna take like that repetition of, okay, this is it. And when you are doing your coding challenge, if you can, and if it helps you, talk through it when you do it. I talk through my code even now. I was on a work session like about a month ago. It was like a full-fledged work session. I'm writing my code. Everybody else doing something on the call. But I literally was like, okay, I'm getting from this table, that table. And I was like, oh, I ain't on mute, am I? And it was like 8 people on the call. And they were like, no. But like I literally talk through my code because to me that helps me. That helps me like take it from like abstract to like what am I doing? So when you are by yourself, practice and like just talk through it a little bit. Okay, I'm getting this data from here, this data from there, you know, and just walk through it. Please, 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 if you get caught up on your coding challenges, hit me up, send me a screenshot, email me, put some time on my calendar. If I don't have time within that week, I will move some things around to accommodate you, to make sure that you are confident in what you're doing. It will take some practice. It will. It will. But I promise you, the way you're feeling now, when you keep practicing and keep doing it, you're going to look back in like a month or 2 months and be like, oh, okay, that's all it was. It's just going to come with like over time, which is why you got so many coding challenges, even after the session. Any questions? Okay. Okay, I see y'all in the chat. Okay. All right. Thank y'all. And if we don't have anything else, thank y'all so much. Please get some rest tonight. Do your coding challenge. If you can't figure it out or need some extra support within this capacity, just put some time on my calendar and we'll walk through it. All right. Good night, y'all.